Good afternoon, students. Look at the column in the textbook, more to know. Here they are given importance of magnetic field in the medicine field. That is two main organs in the body, human body, that is heart and brain, will produce magnetic field. And the magnetic field inside the body forms the basis of obtaining the image of different body parts, and this is done using a technique called magnetic resonance imaging, that is MRI. I think you all heard that doctors or any elders or in the film or anything, we learned that we need to have MRI scan or something like that, right? That is nothing but this magnetic resonance imaging. So here it is nothing but it will give the image of different body parts. In short, you can see that MRI is magnetic resonance imaging, image of internal organs in the body obtained by magnetic field of organ. This is an extra information we need to remember this. Along with this MRI, we have one more term was given the extra information, that is galvanometer. Galvanometer. See, we saw many things like the ammeter, voltmeter, like that, right? So this is also same kind of instrument or a device. Galvanometer detects the presence of current in circuit as well as direction of this current as well as direction. But what is ammeter do? Ammeter only give the current reading. Current reading. Ammeter gives only current reading, whereas galvanometer gives both current reading as well as direction of current. So galvanometer, it is an instrument that can detect the presence of current in a circuit. It also detects the direction of current. Ammeter shows only magnitude of current, whereas galvanometer shows both direction and magnitude. Now what is both direction and magnitude? Direction, this one, magnitude is nothing but quantity, that is reading. Ammeter gives only magnitude, that is reading. So these are the two extra information which are given in the textbook. Now let us go to today's important topic of this chapter, that is electric motor. See, this is very much important. Here we need to study first the principle of electric motor, and the next one is figure. Here figure is important, practice the figure. Next the construction of this device, next how it will work, and the uses of electric motor. Let us try to learn about electric motor. See, electric motor, first we learn principle. In principle, electric motor is a rotating device. It is a rotating device which converts electrical energy into mechanical energy. See, for 1 marks they will ask what is the principle of electric motor? Mechanical energy. So while writing also we need to write step by step. First principle, that is electric motor is a rotating device which converts electrical energy into mechanical energy. Now let us understand the figure. You need to practice this figure, okay? And how the construction is made in this figure. This is a simple electric motor diagram. Students, observe carefully. An electric motor consists an rectangular coil. You can call it as coil or loop. So we did like this, right? In solenoid. The same thing, we took a material, or here this is copper, insulated copper wire. We made it in the shape of rectangular wire. copper coil, we call it as coil, which is taken or placed in between the permanent poles of magnet. So this is the first step of construction. A rectangular coil is placed between the poles of magnets. Then the end of this coil is connected to the split ring. Observe, we have some offering here, we can call it as semicircle, or else we will call it as split rings. What is that? Split rings. So the end of the copper wire, the end of the coil is connected to this split ring. Half of the split ring is called as P and another half is called as Q. Okay. Now this inside the coil, inside the split ring. Inside the split ring is isolated. That means which does not allow the flow of current. Okay, understood? You need to understand step by step. Then while writing the construction, we need to write this step by step, how we constructed. Now the outside the split ring is attached to stationary brush that is called as X and Y. So outside the split ring is attached to stationary brush X and Y. Later on, these stationary brushes are attached with battery and plug key. This is how we constructed the figure, or this is how the figure looks. Now see, in the figure, the positive terminal here, so current starts flow from here to X brush, later on from P to it will go to A, B, C, D, then come back to Q, Y, then it will flow back to negative terminal. So this is the construction. Let us quickly see. You need to write the first point is an electric motor consists of a rectangular coil placed between two poles of magnetic field A, B and C, D. And observe here, these A, B and C, D are perpendicular to magnetic field. So this is the direction indicating the magnetic field lines, and here the coil A, B and C, D are perpendicular to magnetic field. And the ends of the coil are connected to the two halves, that is P and Q of a split ring. The inner sides of these halves are insulated and attached to an axle. So here these P and Q are attached to an axle, right? Now I am writing the diagram. Make sure you write it. So we have something, axle like this, a big rod. So this is attached to this split ring. So axle. And this is our second point. And the next is the split rings are arranged on an axle so that they can easily rotate. So since it is attached to this split ring, this axle will rotate. And next I will show one more video. You can easily understand how exactly this electric motor works. This is our third point in the construction. And the next point is the outer end of rings are in contact with stationary brush, that is X and Y. Right. Now this is the points comes under construction. You write this diagram, later on write the construction. Now let us go to the working part. It is also very easy. Now observe the working point. First let us start from the current. As I said earlier, current starts flow from positive terminal and A, B, C, D, then it flows back to negative terminal. So first we need to show the direction of current flowing in direction. It will flow from A, B, C, D in the coil. This is the first point, and the next point is in the construction. We have magnetic field lines, right? See, observe this coil here. A, B and C, D are perpendicular to magnetic field, whereas B, C and A, B are parallel to magnetic field. The that is nothing but the current flow between AB, CD is perpendicular to magnetic field, and the current flow in BC and AD are parallel to magnetic field. This is our second point in the working. Now, in the last class what we studied? Fleming's left hand thumb rule, right? Now, using that, let us give the direction of force acting on this coil. Now, we know the direction of current and we know the direction of magnetic field. Now, we need to find out the direction of force. So, let us take our left hand. So, as I said, this is what? Force FBI. B is what? Magnetic field, and I is what? Current. So, let us take this middle finger like this. So, this is divided because current is flowing this upward direction, right? So, this is, and what is this? This is magnetic field lines which was flowing like this. And what is our thumb doing? Thumb is facing towards downwards, right? Hence, the force is pushing towards downwards in the coil AB. Okay, so just let us find out on either side. That's it, it's more than enough. So here the force is downwards of this AB coil. Now what happens to this side? So this side, here observe, the direction of current is different. This is downwards. So our middle finger should come like this. Now observe this thumb finger. Thumb finger is now showing upwards. So what happens here? As this magnetic field is this way and current is this way, and force will be flowing upwards. Understood, right? Try to do along with me, or else when you are writing this diagram, use your left hand and apply the left hand thumb rule. Now we understood third point also, using Fleming's left hand rule. We understood the direction of force. This is our third point. And next, another important point is, see, as I said, what is electric motor? Electric motor is nothing but a rotating device. It will rotate using its split rings, P and Q. So now what happens when it rotates? It will change its direction, right? So when it completes its off of the rotation, what happens? This side Q will try to come this side, and this P part will go to this part, right? So now when the rotation completes its off part, we need to see what happens to our rectangular coil. Now let me write the same diagram with after completing half a rotation. So we have like this rectangular coil which is connected to, what is this? Split rings. So when it starts rotating, this part, Q part, means after the off rotation will come to this way. This will become Q, and what happens to P? P will come here. Okay. So this will be our stationary rings. Now we have like this, right? When half a rotation takes place, it will come to back side to the front. So what happens? The interchange of these coils happen. That means AB will go to this way and CD will come to this way. So this is D and B. And everything will be same. Only the coils, the direction will be changes. So as it is, we have a positive terminal here and a negative here. So current will flow in the same direction. So only we need to remember the names of the coil. So force will also flow this way. But what happens here? See, while naming, the force will be downwards from D to B. Here the force will be upwards from A to B. When the split ring completes its half of the rotation. So understood, right? No confusion here. So hence, using this, we can state that as the direction of electric current is reversed, the direction of force acting on A, B and CD also changes. So it's a very simple, only some 3 to 4 points you need to write under the working. This diagram is not necessary, just for your understanding purpose I wrote here as well as in the notes. If you want, just write down, but in the exam no need to write, you just make half of the rotation completed, these things will happen, that is current will reverse as well as the magnetic force. So these are the what we learned. Principles also important, and how we construct it, that is also important, and working. See, don't forget, you need to draw the exact diagram, that is not magnetic fields, and we need to show the direction of magnetic field and our coil which are connected to the split rings, that is P and Q, and we have a stationary brushes X and Y. See, we have a long rod which is called as axle. So if you take like this, if we draw our wings to this axle, this is what we get, wings, 3 wings, which we can observe in our fan or in electric grinder. This will be rotating. This is what happens to the electric motor inside of any an appliance. When this starts rotating, this wings also keep turning. Just imagine how the grinder mixer will keep rotating, or our fan. Let us see 2 more important points, that is, see, first we have commutator and armature. See, let us see what is commutator. A device that reverses the direction of flow of current through a circuit is called commutator. Listen carefully. A device that reverses the direction. Here, observe again this diagram and see which is the device here helps to rotate both magnetic field as well as current. That is our split ring, right? Split rings, when it completes its off of the rotation, it will change both the direction of current as well as magnetic force. So here split ring acts as a commutator. Now next what we have, armature. Armature is nothing but, so here we have taken a coil, insulated copper coil. So this rectangular shape. So just to recall the solenoid, we took an wire which have many coils, and we inserted one soft iron for the better producing magnetic field lines, right? So in the same way, this coil will wound on any soft iron, and that particular device, that means looping this wire on any soft iron, is called as armature. So listen carefully. The soft iron core on which the coil is wound, including the coil, is called armature, and it enhances the power of the motor. Now let us see how practically this electric motor works. We have a rectangular coil which is named as ABCD and which has 2 terminals, and this rectangular coil acts as an armature and is placed between north and south poles. And observe, the ends of the coil is attached to the split ring which is named as P and Q, and this split ring acts as a commutator. Next, observe, we have a axle which is a long rod inside the split ring, and these split rings are in contact with brushes. They are not attached, but they are in contact with brushes, and these brushes are completes the circuit. When the electricity passes, it will run like this. That is, electric motor is nothing but a rotating device, and this keeps on happening. Based on this, we need to find out the direction of current and the direction of magnetic field lines. This is how electric motor works. Now let us see commercial uses. Commercial uses are nothing but where we can use this electric motor. So that we have 3 points. is one is an electromagnet in place of permanent magnet, and large number of turns of the conducting wire in the current carrying coil. That is nothing but we have only one rectangular, that is ABCD, right? So if you make large number of turns like this, current on the current carrying coil. And the third one is a soft iron core on which the coil is moved, that is nothing but armature. So these are the places where we can observe, where we can try to fix these motors. Okay. Now if we come to actual uses or application types, we can use these electric motors, that is nothing but uses such as electrical appliances, that is electrical fan and washing machine and electrical grinder. These are the uses or application we can say under the uses. Now we learned working of an electric motor, construction, and as well as a principle. See, principle is very much important. They will ask for 1 mark. So try to understand this complete topic and solve the homework question and submit me before 4 o'clock.